Okay, now looking at multiplying, okay, multiplying these complex numbers, okay, these groups. Again, it's so similar to just to how you would do it with thinking of it as a variable, okay, like an x. So again, think of these as like 7x times 3x and how you'd multiply those, right? And that's so similar. So 7x times 3, or sorry, 7I times 3I. If you do 7 times 3, right, you can just multiply those like normal, 21, okay? But when you do I times I, right, even though these are imaginary numbers, you would still get I squared, okay? And that still is a thing, okay? So think about this, though. Think about this. If I have I squared, I'll erase this in a little bit, but think about I squared. Again, what is I? I is the same as square root of -1, okay? So really, I squared would be saying I times I, or square root of -1 times square root of -1, okay? And then what's the square root of something times the square root of something, right? Or square root of something times itself. So if I said, right, think about this. If I said the square root of 4 times the square root of 4, okay. Well, what's the square root of 4 is 2, right? And then, so this square root of 4 is also 2, okay. And so 2 times 2 is 4, right? So basically, what's happening here is that the square roots, instead of simplifying it and then getting your answer, you can basically think, okay, the two square roots will cancel each other out, and I'm basically left with what's inside. Okay, so same thing here. The square root of -1 times the square root of -1, drop the square root off. So I squared is the same as just -1. Okay, so when I have 21I squared, again, really that's saying 21 times -1, and 21 times -1 would just be -21. Okay, so that's how I would simplify that. Okay, so that's a little bit extra to worry about with multiplying, because when you run into these I squareds, just know that basically you don't have to do all this work. I just wanted to explain it. But yeah, I squared turns into just -1. Okay. So keep that in mind as you multiply these, all right? All right, now looking at number 8, 2i times 5. So 2i times 5, right? It's saying 2i times this group, so I'm going to distribute 2i times 5, just like how I would multiply. If it was a variable term, right, it would be 10i, okay? 10i. And then here, 2i times this -7i. So 2 times -7, -14, okay? And then I times I squared, okay? So I have 10i minus 14i squared. Again, I squared changes to -1, okay? And really, so this is going to be saying 10i minus 14 times -1, and so that'd be 10i minus 14 times -1 is -14. And again, I said that minusing a negative changes to, it's the same as adding. So I could say 10i plus 14. And again, oftentimes you'll see in these groups, the whole number will come first, the real number, and then the imaginary second. Okay, so if you don't do this last step, it's no big deal. But really, the official way to write this answer would be 14 plus 10i. Okay, so that would be the fully simplified version of that one. Okay, now I'll do one more multiplication one, and then I have one division or fraction type problem to show you, and then we'll be done for real. Okay. I don't know why I erased that, but okay. So now with this one, right, we have a complex number group times a complex number group. Okay, so we are going to employ my rules of FOIL to this problem. Okay, same rules. So first, 2 times 4 would be 8. Okay, outer 2 times 5i would be 10i. Okay, and then inner -3i times 4 would be -12i. And then -3i times 5i would be -15i squared, right? They both have an I with them, okay? So that's what I get when I FOIL originally, okay? Now I have a couple things left to do, all right? This 8 out front stays the same because it doesn't have any like terms right now to combine with, okay? Look at these two middle terms, 10i minus 12i. So 10 minus 12 would give me -2i, okay? But then look at this too, I squared, okay? So remember this I squared is going to change to a negative 1. Okay. So really this is saying 8 minus 2i minus 15 times negative 1. Okay. So 8 minus 2i. Basically, you can also think of this as negative 15 times negative 1. Either way, it's going to change to plus 15. Okay. And now this isn't an I term, right? Now this isn't an imaginary term. This is a real term. So I can take this and combine it with my other whole number out in front. Okay. So my final answer to this is going to be 23 minus 2i. So there you have it. There's that one with FOIL. Okay. Now, again, one more type of problem. Like I said, we're going to do some division with some fractions, and then that's it. Okay. Okay, so I've got numbers 10 and 11 up here. Okay. Now, I'm not going to go into it because I know this is a long video so far, but basically there's a rule that says we cannot have a imaginary number in the denominator. Okay. I'm sure if you wanted to, you could look that up in another video to see why that's the case, but that's a rule. Okay, so we can't have an imaginary number in the denominator. Okay, not allowed. It's illegal. Okay, so we have to figure out a way to say, okay, if I was to simplify this, it's not simplified right now because there's a imaginary number in the bottom. Okay, so again, I have to figure out a way to say, okay, how could I like cancel this I, or how could I make this so that it is no longer has an I down there? And again, the key is going to be this I squared rule. Okay. Because, right, this I squared turns into a negative 1, and then that number turns into not an imaginary number anymore. So I want to think, okay, how could I turn that denominator into an I squared? And that's easier for this top one, right? If I just multiply by I on the bottom, right? 3i times I would be 3i squared, and that's going to work out, okay? But, again, there's these math rules that I have to worry about, right? I can't just multiply just the bottom of a fraction. Okay, I have to multiply. If I want to multiply this by not like changing it, I have to multiply by a version of 1. Okay, and something divided by itself would be considered 1. Okay, even if it's imaginary numbers. So I have to multiply the top by I as well. Okay, and that's going to be totally allowed. Again, because all I'm worried about here is this rule. I can't have an imaginary number in the denominator. Okay. So if I multiply this I here, that'll turn it around for me. But again, I have to change the top then as well. Okay, so watch what's going to happen. I distribute across the top here this I. So that's going to do 4 times I. Just lump them together, 4i. And then 2i times I gives me positive 2i squared. Okay, so that's what I have on the top when I multiply this I. I'm going to have some simplifying to do there. Okay. But on the bottom here, again, this is what I'm worried about. 3i times I, 3i squared. And again, that's why I did this. I wanted that to happen, okay? So now further simplifying this, let's change these I squareds to negative 1. So 4i plus 2 times negative 1 over 3i squared is going to be 3i squared is going to be 3 times negative 1, okay? And then simplifying that, so it's going to be 4i minus 2, right? 2 times negative 1 would be negative 2 over 3 times negative 1, negative 3. Okay. And then I would try to reduce it if I could, but I can't for this one, right? Because 3 doesn't divide into these evenly, and I can't reduce. Okay, so this would be it. Okay. Again, like I said, if you wanted to write it the official mathematician way, you could write the positive 4i after on the top. So you could say negative 2 plus 4i over negative 3. But again, for me, the top one is acceptable. Okay. Now, number 11 is a monster. That's why I saved it for last. Okay. This one. Okay. Again, this one, number 10, was a little bit easier because all I had to do was multiply by I over I, or that's a version of 1, to get that bottom to no longer have an imaginary number. Okay. But I'm going to have to use something here called the conjugate. Okay, conjugate is a fancy math word for it's kind of the opposite, or the sign is the opposite, okay, of what's in the original group. Again, my goal is still the same. I can't have an imaginary number in the denominator, okay? So this conjugate, you're just gonna have to trust me, and then I'll show you how it's gonna work out. this conjugate is going to allow that to happen. Okay, so look, again, all I'm really concerned with is the bottom. Okay, and again, I have to worry about my fraction rule where I can't change this number, so I have to multiply by a fraction of something divided by itself. Okay, and again, the bottom is what I'm worried about. I want to cancel this I out so that's not imaginary anymore. Okay, so I'm going to multiply. This is going to be the conjugate. 3 minus 4i. Okay, so that sign between the two terms is the opposite of what it was originally. Okay, that's going to work this out super nice. Okay, but again, so that's the good news. This is going to cancel out. The bad news is I have some work to do up top. Okay, so I'm going to FOIL. Okay, I'm going to FOIL across both the top and the bottom. Okay, so I'm going to FOIL. Draw my parentheses there. Okay, so if I FOIL, again, on the top, I have a big fraction here. On the top, 5 times 3, 15. 5 times negative 4i, negative 20i. Negative 2i times 3, negative 6i. And then negative 2i times negative 4i. Lots going on here. Negative 2 times negative 4 is positive 8. I times I squared. Okay, so that's just multiplying the top by this conjugate group. Okay, and you might be saying, well, why didn't you do the conjugate here as well? Make it 5 plus 2i. Again, that breaks our rule of, right, that wouldn't be a version of 1, right? I have to multiply by this. And again, all I'm worried about is this bottom. You can have an imaginary number in the top, you just can't have one in the bottom. Okay, so I want to cancel out the bottom. So this will work out, okay? So I just have to FOIL the bottom here, okay? So 3 times 3 is 9. 3 times negative 4i is negative 12i. Here's going to be the key. Watch this. 4i times 3 is positive 12i. And then 4i times negative 4i is negative 16i squared. Okay, so watch how cool this is. Okay, you've been trusting me up to this point. Now you're going to see. On the bottom, again, what's my goal? My goal is to get the i's to cancel out on the bottom. Okay, look what's going to happen. Okay, right now I have 3 i's. You may be like, oh, geez, we're in trouble. But look, negative 12i plus 12i, what's going to happen to those? They're going to cancel out, right? Negative 12 plus 12 is 0i. That's great. Okay, so that cancels. Okay, and this I squared, what's that? That's going to change to a negative 1, right? So that's not going to, yeah, that's not going to be an I either. So when I multiply by this conjugate, all my i's are going to cancel like I want them to. Okay. But the bad news is, so like I know that it's going to work out well, but I just have a lot left to simplify. Okay, so let's do that. Let's simplify it and then we'll be done. So let's combine these two like terms. So negative 20i minus 6i be negative 26i, right? But that 15 first. So 15 minus 26i. And then positive 8i squared. Again, that would be positive 8 times negative 1. Okay. It can be very tempting here to try to do more than one thing at once. And again, some of you all-stars out there might be like, okay, yeah, I can do a lot of this in one step and be done, but you make more mistakes that way too. Okay. So just be careful. Again, these canceled, so all I have left on the bottom is 9, and then negative 16 I squared. That's going to be negative 16 times negative 1. Okay. All right, and then so I keep going, right? This is going to turn into minus 8, and this is going to turn into plus 16. Okay, right? Because of these multiplying it by negative 1. So then if I combine them, right, positive 15 minus 8 gives me 7. And then minus 26i. Okay. And then 9 plus 16 gives me 25. Okay. And then I can't simplify it any further. That is it. Okay. So look at that. A lot of work going on there. All right. But that is all. Okay. So thank you for following. I know that's a lot, but that's all about those imaginary and complex numbers. Thanks for following.